Good afternoon, and welcome to the last of our Data in Dialogue sessions for the Chicago Studies program in the fall 2020 quarter. Today, our presentation is being done by Nico Marchio, who is a data scientist with the Mansueto Institute for Urban Innovation here at the University of Chicago. I'll let Nico introduce himself and the Mansueto Institute in just a moment, but first a word about Chicago Studies. Chicago Studies is an initiative of the college that aims to help all members of the college community to more deeply engage with, study, discover, learn about the city of Chicago and the resources that it has to offer, while thinking critically about the ways in which the life of the city impacts the life of the mind for all of us in the academic community of the university. We're excited to have you with us today. For those who were not able to join us in real time, this is available as a recording on the Chicago Studies website, which is chicagostudies.uchicago.edu. Be sure to check out the website and all of the other content that is available there from our other events this quarter, as well as to learn about things that are coming in the quarters to come. All of that said, I'm now going to hand things over to Nico Marchio to take it away. Thanks, Nico.
Hi. Sounds good. Give me 1 second. My presentation screen disappeared. Let me grab that. Okay. For some reason that. There we go. There. Cool. There we go. Sounds good. Let's present that. Okay, everybody can see that okay? Okay, awesome. All right, so my name's Nico Marchio. I'm a data scientist at the Mansueto Institute. I've basically, kind of my role at the Mansueto Institute is I help faculty and students on research projects that involve data science and quantitative research methods, and also kind of create like mentorship opportunities for both undergraduates and like research assistant opportunities for graduate students. So Mansueto Institute, not sure if you've heard of it before, but it's a research institute on campus that studies urban science. And so we're really interested in basically the fundamental processes that drive, shape, and sustain cities. And we are very interdisciplinary. And so we like to work across different domains and departments and perspectives and methodologies for understanding cities and integrate those into like a synthesis that gives us kind of a broad framework to really understand what's going on in cities so that we can better develop solutions to problems that are facing them. And so, yeah, that's kind of an overview of Mansueto and what I do there. Today, I'm going to be doing basically a presentation on data storytelling using data from the Chicago data portal. And so, there's kind of, there'll be a lot that I cover today, but there's kind of two different sections to this presentation. There's like an overview of data visualization best practices, and then I kind of dig into like an actual worked example that everybody will be able to do on their own if you'd want to run the code after this. But it's basically like a soup to nuts, beginning to end recipe for using data from the Chicago data portal, addressing a real world problem that is facing the city, and then developing some like analytics to make sense of the problem and potentially think about solutions. And a big part of this is not just like looking at data, but kind of thinking about like how we even develop questions in the first place and how we even think of solutions. And data visualization is actually a really important part of storytelling because, we can run like regression analyses and, dig into the statistics, but visualization is really powerful in seeing like maybe the big picture and patterns and connections. And so that's going to be the focus of today. I've sort of built this to be a presentation that anybody could see. So if you have no programming background whatsoever, that's perfectly fine. If you do have a programming background, that's great because then you could probably make use of this code a lot faster. But before I kind of dig in, I was a little curious to see what level of experience people have in programming. I don't know if we can do like a quick show of hands. Has anyone ever used the R programming language before? And if you can give like a little thumbs up, guy, if that's the case. Okay, we got a couple. 1, 2, 3, 4. Okay, so in that case, I think we've got about half of everyone, or maybe a little bit more than that, giving me thumbs up. So I'll get in the weeds a little bit in terms of like what I did with the code, and hopefully that'll be useful to everyone. Like I said, everything is online, pretty well documented, and if you have R installed on your machine, and the environment's doesn't have some weird stuff going on, you could just pull up this script and start running it on your own when I get into it. And I'll direct everybody to the GitHub link, so you can just literally copy the code and go along with me, or you can just kind of relax and watch and then run the code later. Yeah, so a little bit about like my portfolio of things that like visualizations that I've built before. One thing I wanted to plug maybe is this map that I built last year called for the Million Neighborhoods Initiative, which is a project where we attempted to map all the informal settlements in the world, in at least the global south. Informal settlements are like oftentimes called slums, and they're basically communities that are very underserviced. So they don't have access to things like water infrastructure, sanitation, electricity. A lot of times they don't even have access to streets. And so like basic emergency services aren't available. Now, we tried to map all of them in the world, but that data isn't always available because we're using OpenStreetMaps, which is a crowdsourced data platform. So it's basically for all the places for which there are data, we attempt to identify slums. And we did that using like some algorithms. I won't get into it, but basically it looks at like the structure and how densely packed buildings are into communities, which is a pattern that tends to correlate with whether or not an area is a slum. And so you can go to this website, millionneighborhoods.org, and kind of like play around with it. This is just an example of some of the visualizations that I've built in the past. Like let's zoom in on Freetown, for instance. You can see this is Freetown. The red areas are likely slums. And when you really zoom in, for instance, you can see these buildings that pop up. And you can see how densely packed they are and how disconnected they are from street networks. This is a really powerful tool if you're in a rapidly urbanizing city and you're trying to really understand which communities are most disconnected and unplanned, so that you potentially just design infrastructure to connect them to basic services. So it's kind of a like fun thing that we built and gives you a sense of the kind of like urban science work that we do at the Mansueto Institute. So kind of pivoting from really global to really local problems in our backyard. That's like the transition to this stuff. Again, we're focused on Chicago. But before really digging into my presentation, I want to like walk you through some principles of data visualization. First I want to talk about the data visualization toolbox. We can kind of go along a spectrum of like how much work it takes to build a visualization. What I just showed you is probably one of the more intensive build outs of a visualization. That involved sophisticated web development tools like JavaScript, HTML, CSS. You kind of need to be doing this stuff for a living to do this. It's not something you could easily do for a school project. And that takes weeks or months to do. But on the complete opposite side of the spectrum, like anybody can make a visualization. You can do it with even hand-drawn viz with a pen and paper. You can use it, Microsoft PowerPoint, Google Slides, and just move around shapes to communicate things. And anybody can really do that. Obviously, you can't do it for like really complex visualizations with lots of data points, but it's a possible way to convey a point using visuals. Next in line of like, if we're moving down a continuum of learning curves, is like spreadsheet software. So like Google Sheets and Excel, they're honestly, like you talk to a lot of people in like the data science world with like kind of good takes on this. Like it's like honestly one of the best data science tools out there, Excel. And you can learn a lot really quickly just with like some quick and dirty visualizations. You just like highlight some data plots that are in a pivot table, and then boom, you have already a chart and you're visualizing. And so that's something that I really respect in terms of like having in one's repertoire. Obviously, there's the limitations. You can only really visualize, you know, Excel can only handle like 60,000 rows of data, and you kind of need to summarize things when you're using Excel. Then you have like, this is more common today, like interactive dashboard tools like Google Data Studio and Tableau. These are great things to learn. They're really also a pretty low learning curve. It's sometimes a little kludgy what you create with it, but I think it's powerful for making interactive exploratory data tools, especially when you kind of have an audience that you're not like guiding the analysis for, and you want them to kind of like piece together patterns. That's like a good use case of that. Or if you're just trying to learn about your data, those are good options. Then you have like GIS software, QGIS, ArcGIS. A lot of people here have probably used those before, so don't need to get too deeply into them, but they're basically like GUI based like tools that allow you to like drag and drop spatial data, click through a menu, and build a visualization pretty easy. And that's good for like choropleth maps and things like that. Problem with it is you need to click a bunch of buttons to like get things, so it's not very automatable. Then you get into Python and R, which I think is like, if you can set a goal for yourself in terms of learning those things is pretty important. If you want to do data science visualization, especially in the professional context. And that is very replicable, very automatable, highly customizable. You can work on huge data sets. And so I would just say like, that's what I would say is, if you're going to make a goal to learn those things, because you can do a lot with them. But then again, you don't have to, and I wouldn't feel intimidated. There's lots of resources online to learn that stuff. You just have to put in the time. So with all that said, you don't need software skills to create powerful data visualizations. And I want to hammer that home. I don't know if people have ever learned about or know of Mona Shalaby. She used to work for 538, but now she has her own Instagram and website, and creates like really powerful, poignant visualizations with data, but they're kind of hand drawn. And you can see right here, these are you can see like, this is the percent of residents in Illinois who are Black, and then the percent of residents or COVID-19 deaths that are Black, and that share. And you can see that's a pretty impactful visualization that communicates the point. And there's no like data technology involved there. And so just kind of a good thing to remind everyone. So kind of thinking through like, people think of like data visualization as this kind of like art form, and like there's very subjective decisions involved. And I think that is true to some extent. There's a lot of subjectivity in this, but it's also kind of a science. And there's frameworks and templates to organize our thinking on how we express visualizations and data. And so you can kind of, this is like a canonical way to do this. Like I would say that start with this. You can kind of think of it in like 4 different bucketed categories of ways of looking at data. You have comparisons, relationships. So you have like 2 different dimensions. You're trying to look at a pattern relationship. Is it positively correlated, negatively? Is it linear, nonlinear? Distribution. And so you're trying to look at the frequency of some kind of category or class within a population. And you might see that there's some abnormal distribution or bimodal distribution. These are really important questions. And then compositional questions. So let's say you have different classes like racial categories or occupational categories or socioeconomic categories, and you're trying to look at like, the relative proportion of these things. These compositional charts are useful. And so that's like time trend. You could look at composition over time, or you could look at competition in a snapshot of time. And kind of getting back to like, the comparison is also kind of used in that way. It kind of depends. Like bar charts are probably one of the most powerful visualizations, so simple to read, and it allows you to really just quickly assess relative magnitudes of things in different classes. And so that's, I would just say like, this is a good way to think about it. And when you're like, where do I begin with this? Well, you could download a chart chooser. They're all over the internet. You just type in chart chooser, and like Google will give you like 20 different versions of this. And so like, this is literally like a logically flowed flow chart. It's like you choose your own adventure, and there's branching logic, and it kind of points you to the right visualization that you should use based on what you're trying to show. And so I really recommend, like, when you're starting out to use this kind of stuff in terms of thinking, like, what should I even build in order to express the data that I'm looking at? And I would say, like, if you want like data journalism gurus or like people to really look to, I would recommend Financial Times. Like, I think their visualizations, they aren't super fancy. They're very kind of like, they're not like super elaborate New York Times interactives. They're just like, let's get the point across as quickly as possible. And they have this website, ft.com vocabulary, where they just like totally made this big taxonomy for thinking about this stuff. So I'd really recommend bookmarking that website. Okay, so that's kind of some like, how do you think about visualization? That's like its own presentation. We could go in a rabbit hole, but we need to kind of keep moving on. Another thing that's important, and this is again one of these kind of questions that people have, like, isn't data visualization, it's kind of like arbitrary in terms of like the colors and fonts? It is a little bit, but here's the thing. These are tools that you can use to help inform these choices. So the first one I would say is this Color Brewer website. Click it, and what it does is it helps you just get like a bunch of color hexes that look pretty together, and also for logical reasons. And so let's say we want a sequential pattern. Let's say we have like 8 different categories. Okay, we want a sequential pattern. So this is like for like a unipolar scale. So it's like any scale that's like from like not a lot of to a lot of this thing, then this is a good color palette. If you have a diverging pattern, so it's a bipolar scale, so it's like negative to positive, then like you'd want a diverging scale and then choose one of these colors. And then if you want a qualitative thing where it's just like discrete classes that aren't along a continuum, then you'd use these. And this is just super useful. So I'd recommend like people start here, copy the color hexes, and that's what you use. Another option is this thing, color space. And so let's say you have one color that you're in love with. Let's say you really like this like teal. Okay, you go here, you enter that color hex, okay, and you click generate. And then what it does is it generates like a pretty gradient that is like kind of builds on that color palette. And so that's pretty useful too, in terms of figuring out which colors you should use. Okay, so those are, and then in terms of fonts, these are all open source fonts that you can use that I think look good in plots. They're clean. And so maybe this is not like academic paper stuff, but I think these are good ones. Just my thoughts. So, okay, colors, fonts, how to choose plots. That's next we kind of like, okay, what about the substance of the visualization? All right, now the way I think about this is these are like, I screen grab these things from John Schwab's website, PolicyViz. Okay, so this is repackaging somebody who's got opinions about data viz, but I think I agree with these takes. First is annotate your data. Now, with visualizations, you want it to be doing as much of the storytelling for you as possible. So you want somebody to be able to pull up the viz and kind of come to a similar conclusion as you do when you're presenting it. Okay, and so ideally you shouldn't have to be around explaining it in order for it to make the point. And so when you include annotation of data points, you can call things out and call attention to it and label information that might be kind of in the subtext. You might know that this outlier is this place, but your audience doesn't. And so let's annotate. Next, reduce clutter. Like, there's no reason to create these like 1980s like 3D plots unless you're trying to like be like, you know, sort of like that's your aesthetic or something. So like, let's cut the 3D junk with like all these grid lines. Let's keep it clean. All right. All right. And so that's a good thing. You just don't want too much noise and to overwhelm the audience visually. Next, include titles that are descriptive. So it's like, if you have a finding that you're trying to show in the plot right here, include that in the title. Okay, so it's like, we're showing increasing growth and inequality over time in these areas. Say that in the plot. subtitle, okay? So the first thing you read is the finding. Make it simple on the viewer. And then you can get into the guts of like what's going on in like the subtitle or into like a little blurb below the visualization, okay? Then finally, if like there is like a thing within the plot that you're trying to call out, highlight it. So just layer in like a circle over it and draw a line, like look at this thing right here in the plot, and use that with all sorts of like enclosures and visual cues, okay? So there's no like, you just like write on the whiteboard if you want to like highlight something. So just do that with the plot. Okay, so just to kind of wrap up these like other visualization best practices, keep in mind your audience. So if it is an academic audience, maybe you want to present it like to these like super expert people who kind of understand this stuff already, or like there's like a way of communicating to them, you can make it that way. And so what I'm kind of giving you is generalized feedback, but like academics have kind of different preferences in terms of like how they like to see visualizations. Then I would also this is like a thing that I think we're all super aware of, but it's worth mentioning, is that like this right here is like the same exact plot, but they played with the axes. And so generally speaking, you want to show the 0 on the axis, and you don't want to truncate the axis, because what it does is it magnifies the gap, but the gap is actually tiny. And so, you know, this is something that people oftentimes do when they're trying to like kind of embellish a difference that really doesn't exist. And so, you know, it's more responsible data visualizations to always start with the bottom 0, but there could be exceptions to that, obviously. Throwing a bunch of junk into one plot, I'm looking right up here with this try small multiples, it doesn't make a lot of sense. So try to split things out into different pieces, just makes it easier to digest. And you know, it's just like a lot of this is basic stuff, but you know, you can go down these checklists when you go through visualizations. And so that's just like a lot of this is common sense. I'm not like some visualization guru. This is just like some tips that I've found to be helpful over the years. And so like you can basically know like 99% of my visualization best practice knowledge now. So this is also some tips that I have. I was a consultant for 2.5 years in a tech company, where I was like the data science consultant. So I was building visualizations for like executives and clients who are like, I just need to know what I need to know really quickly and keep it simple. And so these are some tips that I've extracted from that experience. One, move slowly, keep it minimal, try to limit one idea per slide. Obviously, I'm not doing that right now. I'm giving you multiple ideas per slide, but with, you know, when it's high stakes and you want your audience to walk away with like a couple basic insights, you need to just make those super memorable and super simple. And you're kind of successful if they walk away like with 3 different findings in their head that they retain. So try to keep things simple. Then like also like when you have a plot, like just answer these basic questions. What are we looking at? So walk through the components like the title, axis, labels, legend, whatever. Like, what is the basic insight? You should be able to boil it down into one sentence, and just highlight that. And then does the audience get it? You should ask like, do you get this? Does it make sense? And like do it in like a way that can like cut down in the expert awareness gap, where when you become an expert in something, it's like impossible sometimes for you to imagine the world in a way that a normal person thinks. And so it's important to always check that by asking people, does this make sense? Also in like a non like dismissive kind of pompous way. And so, okay, so that's it. And then like iterate, cut. Like it's okay to throw like 50 slides into the appendix, and that's totally fine. But if you make a cool slide, but it doesn't relate, throw it in the appendix. Maybe it comes up in the Q&A. All right, and so that's basically the like consulting kind of hard-nosed data visualization suggestions. Obviously, it doesn't make sense for all situations. All right, so now we're getting into the Chicago Data Portal stuff. We've kind of done this front loading of like best practices. Now let's put it into action against real world data. So the problem statement that I want to look into in this analysis is the Chicago data portal, as many of you know, has like tons of cool data related in Chicago, right? I'm a bicyclist. I like biking. I kind of think about those problems occasionally. And so I use this opportunity to dig in some bike data. And one of the interesting things that's happened over the past year, partially related to COVID-19, is e-bike sales have soared. I mean, we're seeing like 84% growth month over month over month at the beginning of like the bike buying season. And so the rising use of e-bikes and like all these like micro mobility devices is actually really interesting because it presents an opportunity to create a more sustainable transportation system. We could take cars off the road, get people to work in about the same amount of time, replace it with like a relatively cheap piece of technology relative to a car that is completely sustainable, 100% electrified, it's healthy, it cuts down emissions, like there's probably less like stress on roads, so it cuts down on potholes, takes cars off roads because it can reduce congestion. I mean, this like e-bikes could transform cities if like there's wide scale adoption. And so like this is kind of exciting. Like I think this is great. And it also like not everyone's like a crazy bicyclist who will like want to like hustle to work every day, and e-bikes make it easier for like a more people. And so like I think this is an important question is like how can we improve existing bike lane infrastructure or build new bike lanes to accommodate more riders? Because if we're gonna have more e-bikes, we're gonna have more riders. So the method that I was thinking to look at this question is first, let's look at which routes have more bike injuries currently, and like kind of retrospectively, in order to identify which areas are most in need of bike lane expansion or improvements, okay? So that's the question. We're gonna address it with data that is exclusively from the Chicago data portal. So the data sets that we're looking at are traffic crashes, bike lanes, track boundaries, and community areas. And we'll dig into those data sets. But the basic workflow is all contained in my R script. And what we do is we programmatically download the data into R. So we're not even like clicking links and downloading and unzipping stuff. We're doing it all within the R environment. We're extracting the bike crashes from the traffic crash data set. Okay, so we're looking at those bike crashes. And then we're assigning the crashes to tracks or community areas, and then we just visualize them. Okay, that's the basic workflow at a high level. Hopefully that's intuitive. And then we will visualize it in two different kind of ways. We're going to make a choropleth map where we highlight the crashes at the tract level, okay? So we can kind of see like where the heat map is in terms of crashes within the Chicago spatially. Is there a pattern? Maybe, maybe not. And then two, we're going to build a stacked bar chart by community area, which gives us more intuition and descriptive information about which areas, which communities, which neighborhoods in Chicago have more crashes than others. Okay, and we're going to just array it that way. Okay, that's it. And so, like to also just kind of like undergird the relevance of this, in 2020, City of Chicago said we're going to add 25 to 30 miles of bikeways. That's like actually not much at all. You can see it's just these color-coded regions. And so like somebody at the city was like, this is where we need to put bike lanes. And so we're going to kind of assess if, maybe those were the right place or not the right place. And also like some studies have found that like the main reason people don't bike is because of lack of infrastructure. And that's a major impediment to e-bike usage. Okay. So, all right. So we're on to the races again. Like I'm not going to walk you through this, but if you don't have R installed, I will share this presentation. I'll actually just dump it in the chat right now. Here, I'm going to dump it right here. This is my presentation. So if you want to like click through these links, get the stuff installed, you should feel free to do that. And so, all right, so that's how you install those things. But like so all the code that I'm about to walk through, and we've got like 15 minutes left before, or like 30 minutes left. So I'm gonna kind of breeze through the code quickly. All of it's available on GitHub. And so I'm also gonna drop this link right here. in the chat, you can literally just grab my code on GitHub, copy it over, and run it. And ideally, if you have all those packages installed, it should just run for you. And so and it will like download the data automatically and all that stuff. And so to kind of do, okay, so I'm gonna do this right here and start walking you through my code, okay? So these are the packages that you need installed. I'm not going to walk through it, but those are the packages. So let's get those installed. And like I basically have 3 different sections, like I was saying in the code that I'm about to walk through. I've got some code that imports the files from the Chicago data portal. That's this initial section right here. Okay. Then I've got some code that processes the data. So I basically clean it up. I combine it together and I make it into a form, like a data frame that is ready to visualize, okay? And then I just take those data frames that are ready to visualize and I visualize them with ggplot, okay? And that's what the last section is, okay? So you can kind of chunk it out. So like y'all have probably like played around with Chicago data portal, but like, you know, the way it works is you like, so for instance, the bike routes data, what that looks like is, you know, you just like Google bike routes and, you know, this is like the Chicago data portal's website. And when you want to export the data, what I do, this is my preference. There's like an RSecreta package where you can actually download stuff from this portal, but I don't like dealing with that. I like just going directly to it. You just click export, and what I do is I right click, copy link address, and if it's spatial, I like to use GeoJSONs. When you're using shapefiles, there's all these additional like files, and I think it's a mess, and so I just like using a GeoJSON. And what I do is you just copy and paste it like that, okay? That's the link address. That link, when you click it, downloads a file, okay? And so what I did is I went to each of the data sources that I wanted, this community areas file, the tracks file, the bike routes file, and the traffic crashes file, and I copied those link addresses, and that's right here for each one of them, okay? Then what I do is, because these are mostly spatial files, I use the SF package and the stread function to read the files directly. And so literally what I do is, that's the URL, that's the stread function, and I run it, and you can see right down here, it like reads the layer in, and it shows the coordinate reference system is 4326. That's important when you're using spatial data. That's kind of like the canonical format for visualizing spatial information. And you know, like you can just then inspect that data right here, community areas. Click it in R, and you can see this is like the community area label, and this is the geometry delineating that area. And these are like neighborhoods. But this process I basically run for each one of these data files. The first 3 are spatial files with like polygons and line strings. The last one is basically traffic crashes. And this is unique because I actually pulled it in as a CSV, because it's the spatial coordinates are just like longitude and latitude columns, okay? And like that's not actually a simple feature spatial data object. So I wouldn't be using the stread for like, which is for importing spatial data. I'm using just like a read CSV, okay? And what I actually do is I read it in as a CSV. I do some like, I filter it down to only the bike crashes. So I limit to the crash type is a pedal cyclist, which is the code that they use to identify bike crashes. I limit to injuries that are like fit into these categories, because I only want to look at injuries. I limit, like there's some like crashes with no longitude, so I like drop those from the data set. And then this function right here, st as sf, what it does is it says take the column longitude and take the column latitude and convert it to a simple features geometry, okay? And so now I'm basically, that line, it turns it from a data frame to a simple features object. And so it's an important snippet of code whenever you want to convert some CSVs with lat lons into a simple features object that you can then visualize, okay? And then I did some like some more data cleaning. I'm basically using, this is a case when, so it's like if then logic. If like the Doreen I column is equal Y, I converted it to a binary 1 or 0, okay? That's what it's doing. So I don't need to get into all this stuff. You guys can probably figure it out on your own, but like that's the basic import step. Once it's in R, it's a lot easier then to work with. Then what I'm doing is processing the data. So one, I'm taking this traffic crash data set. We can like look at this really quick just to inspect it. Like this is the traffic crashes after I've like cleaned it up. You've got like this, you've got some like geometries and all of that in there. So what I do right here is I'm using a spatial join to pull in the tracks into the traffic crashes data, okay? And the Chicago tracks are these delineations, right? With these small areas, and then the traffic crashes are these points of different crashes. And what I want to do is I want to label all of my crashes with the tracked identification FIPS code, okay? And you use ST join, spatial join. And what's interesting about spatial join is not like an inner join or left join where you're joining on a specific ID that matches. What we're doing is like the spatial information contains everything that you need to join the information together, which is actually really powerful. And one of the reasons why it's cool working with spatial data, you don't need ID codes that match. You just need a coordinate reference system that matches. And so that's what I'm doing there. And then I'm basically I'm using like a group by summarize to aggregate this injury data, which is just like binarized counts by the geo ID, which in this case is the tracked ID. So I'm just aggregating, collapsing this crash data by the tracks, okay? So we're going from individual level crashes to track level aggregations. Then we join in the tracks, the crashes data to the tracks data, joining on tracked ID. And we're kind of doing some more data cleaning there. And then finally, that data right here is basically ready to go for our choropleth map, okay? Because we've got basically the track level geometries and we have the summary count at the track level, okay? And then right here, this is for the bar chart and that we're about to make. And it's a little more involved and I kind of maybe, I don't know how we're doing on time, but I can kind of like walk you through it. But basically what I'm doing again is I'm using the traffic crashes data, but instead of aggregating by the tract, I'm aggregating by the community area, okay? These are larger delineations and I can like show you, like here's the what a community area looks like in Chicago. Right over here, see this? That's community area. When we want to look at a tract, that's like this. Okay, that's a tract. Cool. So we want to like organize it by community areas. So it's kind of similar workflow as what we did with the tracks, right? We take the traffic crash data, we basically aggregate it by the community area. We'd already joined in the community areas right in this step right here using the spatial join. And basically group and summarize again by the injuries. I kind of do I create an injuries total column by just summing these things together. It's pretty simple math. We select the columns that we're most interested in. In this case, it's just the community area label and the different injury columns. We use melt, which basically reshapes the data from a wide format to a long format. I'm going to show you right here, like what that means. Like, so not everybody understands melts, but this is what the traffic crash summary table looks like in this wide format, this is what it looks like in the long format after we run that melt operation. Okay. So instead of so what we got is we're pivoting on the community area, but instead of having a column for each of the different injury types, all the injury types are now in a long format in this variable column, and the value is alongside it, okay? So this is a super powerful way to like change your data, because long format is your friend usually when you're working with data, okay? Because you can just do a lot more. You don't have to run things over each of the different columns. You can just do it over one column, right? And so, we do that, we get it in the long format, and then we can just we do some more group by. So we're grouping by the community area, and we create a share. So like the total share of injuries by type. And this little snippet right here is like kind of jargony, but it's important for the visualization, and I will kind of reference it later. But and then okay, the visualizations themselves it's pretty easy to do in ggplot2, even though I have a lot of aesthetic code. I will run through the choropleth. So one thing I do right here is I cut out O'Hare. O'Hare is like a useless part of Chicago because nobody lives there. So let's cut out O'Hare. It just takes up space. That's what we do there. And let's visualize. And so use ggplot. You use this. I'll show you how I build the plot from scratch. So first, let's include an overlay of the outline of Chicago. Then let's layer in the traffic crash data. It takes a second. You can see right here, it's not aesthetically pleasing, but we layered in traffic crashes. Now let's start adding some coloration to it. I do that with the scale fill gradient code. And I use these color hexes that I've chosen. Okay, it's looking a little bit better. Added the color. Okay, now let's add in the bike routes. I'm gonna overlay the bike routes. Okay, boom, let's do that. There you go, then blue. So we got the Chicago color palette. We got that blue and red with the flag. And then let's just, everything else right here, it's a ton of code. It's just aesthetic stuff. I'm gonna probably leave it to you guys to figure that out on your own and play with it. But this is a very opinionated idea of what I think it should look like aesthetically. And so we run it and it adds the final labels and everything like that, okay? So there we go, that's our plot. We've got traffic crashes in red, and we've got an overlay of the bike routes, and we have, a data description at the top. These are reported bike crashes 2015 to 2020. So we've got 15 minutes left. Do you want me to go through the bar chart code? Yes? Okay, cool. All right, we might go over a little bit, everybody, but hopefully this is useful and this will be recorded. So the bar chart code itself is, you've all probably made bar charts in ggplot, but what I do here is I basically take the aggregate traffic crash summary data right here, and I'm like, all right, give me only the areas that are in the top 20 in terms of rank. I created this rank value up in the previous code when I was processing it. So give me the top 20 community areas in terms of crashes. And I'm basically creating a factor column. This is important if you want to array categorical information, in this case community areas, in a specific ordering. So I want to order it in an ascending order or descending order from most to last. And so you use a factor to assign that order logic to that particular column, which is community areas. I'm moving pretty fast. And so I'm kind of violating data code tutorial principles, but all right, so you do that. And then we have like a vector full of color hexes that we want to use. That's kind of boring to cover, but then we go here. All right, so first things first, let's just visualize the data. Oh God, that we don't actually. This is like the bare minimum bar chart code to create a bar chart in ggplot2. Okay. Already after running just like 3 lines of code, we can generate a cool bar chart like that in ggplot. So it's pretty awesome. But like I was saying, you want to annotate your data, okay? And so what I want to do is label what these values are, okay? So I'm going to do that with this geom text. Now, this is like a secret guru tip that everybody should take note of that I referenced earlier. This geom text, how do we get the numbers there, okay? How did we get those numbers labeled exactly in the middle of the plot? The way I did it was with this code right here that I referenced earlier. What I basically am doing is I'm doing a position, I'm basically creating a value of the middle position of this stacked bar chart range that corresponds to the x-axis, which is the injury value. And I'm calculating that, and I'm basically telling ggplot right here to put the value, orient this text value according to that position, the pos ID value that I calculated there, okay? I would encourage you to work through my logic on your own, but that is how we got that right there. And that is like a little secret visualization snippet that will probably be handy. And so then after we do that, everything else is aesthetics. And so you run that stuff and boom, there you go. It's done. We used like some like Lato font. We're using kind of nice colors, etc. We label it top 20 community areas by reported bike crime. So that's it. That's the code. Move through it very quickly, and so it's okay to feel a little overwhelmed. It's easy once you understand it, but it'll be a little intimidating. But I encourage you to just like put in the time with the code base, and it will run, and you'll make sense of it. So, all right. That's the visualization tutorial. Now, the analysis is equally important, and that's what we're going to go through right now. So right here we have bike crashes. The basic finding, to me at least, is that bike crashes concentrate in the northwest parts of Chicago. You can see right here, these red spots. It's like this like Milwaukee bikeway. A little bit about myself. I got doored on the bikeway, and I have a permanently crooked finger because of it, for this guy right here. I got 2 like nails in my hand to like straighten it out. It didn't work, and now I got a crooked finger. So it's a dangerous bikeway. And yeah, like I actually got injured like right there. So it checks out with my life experience, but you can kind of see, so there's something going on there. You can also see where like the community areas that tend to have these bike crashes, like we're talking Westtown near North Side, Logan Square near West Side, Lakeview, Lincoln Park. I mean, we all kind of know those neighborhoods. There's probably certain patterns that these neighborhoods have in common. I think it's pretty obvious if you actually look at the demographic data, but we'll get into that in a minute. But one thing that is interesting is like looking at the Doreen incidents relative to, it's like there's a huge discontinuity right here. Like, so there's something weird going on in these communities. I don't have an explanation necessarily, but we have concentration of crashes. We also have a discontinuity and also an outsized number of Doreen incidents. And so that might be important to factor in when we're trying to figure out where to put bike infrastructure. Now, there's some possible explanations to go through. And, you know, this is like, I think where things get really important. You're supposed to interrogate your data and not just like be like, okay, end of story. So one, these are different explanations. I don't know the answer, but I think there's obviously one possibility is that there's just more bikes and more congestion. And as a result, there's some maybe poor bike lane design that leads to just more crashes. So it's just a volume thing. Another possibility, there's a reporting bias. So reporting an incident requires calling the police, and different communities may receive slower service or may be less likely to trust the police in the first place. That's a possibility. Another is there's barriers spiking in other communities. And so because, if you look at the bike lanes, there's fewer bike lanes in these areas with fewer accidents. And so maybe it's so dangerous to ride your bike that people are just doing it less, and as a result, that reduces the actual number of accidents in aggregate. Another could just be this like per trip versus total trips problem. If you did like the rate of accidents, you might see a different pattern. It might just be even across Chicago, and like on a per trip basis, it's about the same. It's just by the volume is higher in these areas, and so that's why. Other influential factors could be something related to demographics. There are some obviously demographic patterns that we'll get into in these communities. And also, like, why do we have all these bike lanes right here in the first place? And if you look at like political influence in Chicago, these communities might have a little bit more clout to get those bike lanes in the first place. And so there could be like different like things going on that lead to bike lanes that lead to crashes. And so I think that's important. Now I'm getting into additional visualizations that that I think tell a deeper story. And these aren't part of my code, but I think I'm including them as part of this kind of like broader analysis that we're doing. If you look at race and income in Chicago, this is not the easiest to read map, but it packs in a lot of information. Those communities where there's a lot of bike crashes are the wealthiest communities in Chicago and also disproportionately white. Those communities without any crashes are disproportionately African American and low income. So there's a pretty clear demographic spatial pattern in terms of the location of bike infrastructure and location of crashes. And so I think that means there's more going on to the story than maybe meets the eye, And I think if we go even deeper, here I'm breaking out more different kinds of indicators beyond just like race and income. You can see that these crashes in infrastructure concentrate in neighborhoods that are white, wealthy, and gentrifying. So they have the highest proportion of white people, highest proportion of bachelor's degrees holders. They also have the political base of Lori Lightfoot and probably a lot of other political leaders in Chicago. High median housing value, high household income, and also location of most of the new residential construction over the past decade. And so these areas that have been highly developed, and they're also very well off. And so maybe like, I don't know what that necessarily says, but there's some other things going on that could lead to more bike infrastructure, that could lead to more bicyclists, that could lead to this problem, and that we might only be seeing part of the picture. And so it's important to know that like this is actually like, we started out with a simple question. Now we're kind of getting into these more complex themes. I think that is like really important, because I think we need to maybe even start questioning our premise. And so kind of getting back into that, how can we improve the question or the method? And I think this is like an important point where it's like, I need to be self-aware, as like, I live in Logan Square, I'm a white guy, I'm kind of upper income, I bike a lot, and I got doored once, and I saw the problem from like that very limiting perspective of my own personal experience. Whereas maybe if I lived on a different community with fewer bike lanes, I'd see it in a completely different way, and maybe cut the data differently. I would look at per capita or like per trip accidents, because it could just be a higher rate. Because actually, I biked down some of those streets like on the south and west side, and they're super dangerous. And so there's probably other stuff going on. And also those communities have maybe a fraught relationship with policing. And so that could also affect reporting biases. I'm okay calling the cops. Maybe not everybody is in that same boat. So these are like really important questions that we only have half the story. And it kind of underscores the point that when we do these analyses, we need to engage other communities and maybe get other perspectives, or build a more diverse research team to safeguard against kind of like limited thinking. And so, or even just go through this exercise of visualization, but then like taking a self-aware lens to it. And so that's kind of as important to like all those like styling, data styling and color coding best practices, if not more important. And so that was kind of like a big takeaway that I want to emphasize as part of this presentation. And so that's kind of everything that I've got for this. Here's the R code. Again, I linked everybody to this slide deck so you can just like grab the code. And so that's that. Does anybody have any questions? I imagine folks have some questions, so. Okay, so I'm looking at chat. Do you have ggplot aesthetics doc you reference besides the basic ggplot help sheet? I don't have any like canonical ggplot information. Like I haven't like made like a aesthetics document ever, but a lot of like the opinionation behind aesthetics is like embedded in my workflow. And so you can like, so for instance, like this right here, the theme function is like contains a lot of the decisions I make about aesthetics. And so you can literally copy and paste that theme function into your code and just append it to stuff, and you'll kind of automatically inherit a lot of my aesthetic opinions. But it's subjective, and you know, I'd recommend everybody like customize according to what you're trying to do. So
Nico, you're sort of an unusually well-informed consumer of data visualizations, and we're seeing a lot of those right now associated with the recent election. I think the spread of COVID-19 certainly leads to everybody having their own kind of visual vocabulary for a lot of data that's pretty significant. As a more critical consumer, kind of what are either the most common mistakes, or maybe what are some of the most common deceptions that you see being practiced in the way that data are visualized and then leveraged in relation to some of these sort of hot current events?
oh yeah, that's a really good question. And I think part of the challenge today is that like we're in this sort of like data overload culture where you get inundated with information, and there's also like a natural impulse to seek simple narratives for complex things. And so you know, people used it, like I even use it this way, to data as like a form of rhetoric and a way to make a point to back it up, because data is persuasive, especially to like, you know, supposedly sophisticated people are sometimes most you're most able to effectively persuade them by showing them data. And so I think one of the challenges I mean I see is like, and this is maybe not the most satisfactory answer, but like I always like look at a visualization and I'm like, okay, like I need to read like about the methodological appendix here, because even like really sophisticated sources that I even trust a lot, like even like the New York Times, like to even make sense of what I'm seeing, I need to know more about it. And there's oftentimes not enough boilerplate explanation about what you're seeing. And so I actually gave this example to like Sabina's class when I presented this, but like the needle at like that election needle at the New York Times, I think that's bad data visualization, because you've got all these like people, even like me, who like I actually worked in like professional polling for 2 years. I'm like, what's going on there? Because you basically need a stats degree to make sense of the thing. And anytime you need a stats degree and read a methodological appendix to really understand what it's telling you, I think it's like very responsible data visualization, especially if you're dealing with the general audience. And so I think if you can't like clearly articulate within like a couple bullets like what's going on, and your goal is to communicate to a general audience, it should be really, it's probably not a great visualization. And I would say it's more important to have a basic insight that everyone can like a high percentage of people who see it can fully understand, than something that's maybe like perfect scientifically valid, but like only like 10% can actually derive the right conclusion from it. And so that's maybe like a critique of like people who are good at visualization. There's obviously like a whole slew of people who are like really dishonest. We just need to steer clear of them. And so yeah.
I particularly appreciate your point about data and data visualization as really a new form of rhetoric. I'd never thought about it such, but I think that's a really salient point. And it occurs to me that to some extent, visualization of data is kind of one of the few remaining refuges of a form of logical positivism that suggests on its surface, by the very construct of what it's trying to do, that, oh, yeah, I'm just presenting something that's completely obvious. When in fact, I'm going to go back to your bicycle example, an awful lot of even the way that the basic question was constructed may have a lot more to do with your personal experiences and layers of privilege than is immediately obvious.
Totally. Yeah. Yeah. I think that's a really good point. And I think it's hard, yeah, to do this, because I think anytime people come at these questions with motivation, whether or not it's like unconscious or conscious, or and there's like a pressure to show something. Like a lot of times people approach research where it's like, I want to show this, and then they back out of it that way. And that all of that but if you do it in a sophisticated way, I think a lot of people will fall for it, including smart journalists, and things like that. And so, and it's like also there's like selection questions where it's like, well, I want to show positive stories, so you show the positive data without showing maybe the negative story within the data too. And so there's a lot of decisions that we make unconsciously or consciously whenever we tell a story, and that's why it is like storytelling. And like, so that we need to like be really critical. And I think like basic things like posting your code, creating methodological appendixes, and like also engaging a broader community and trying to be responsible is like basic stuff that we should always do when we're trying to communicate stuff. So yeah.
Not to suggest that you do any additional work, but that last little list of sort of almost key or consistent ethical practices that you'd recommend to improve transparency, if that document doesn't exist somewhere, it might be a great one to craft as part of, say, an evolving catalog of urban data sets that the Mansueto Institute and Chicago Studies might be working on. And with that, I would love for you to give a quick summary of that little project so that viewers of this know that it exists, and then we'll end the recording after that.
Okay, sounds good. So yeah, I think that's a good point. I don't know if, imagine there are like ethical data visualization gurus out there, but if not, that would be a good thing to exist. Or a compendium of people who've put together similar resources would be useful. And so that's maybe something we can think about. And as related to that, we are currently doing a joint project between Chicago Studies, Mansueto Institute, and the Program of Global Environment to put together urban data catalogs. So we have like an 8-page list of various urban data resources that we're compiling together into more like systematic dictionary of information. So like, the who, what, where, when about data sets, the what is the data set, what's the source, what are the time periods, what are the geographic units, what are the indicators involved. These basic things are oftentimes difficult to wrangle or track down when you're trying to like, you're in the early stages of like doing data discovery in a project. So we want to centralize these things into a document or reference resource. And we have a couple students this quarter working on it, and we're hoping to make that like a publicly available open source thing in the near future that can then just be its own living document that a broader community of students and researchers and faculty can then edit and add to and keep evolving. And so that's to be on the lookout for that.
Yay. Speaking of things to be on the lookout for, this data series will continue into the next few quarters. We have yet to determine the specific programs, but information about these and other upcoming Chicago Studies events will be publishing very soon. Chicago Studies, uchicago.edu/events. Thanks to Nico Marchio for presenting. Thanks to the Mansueto Institute for co-sponsoring this series. And thanks to those who participated. Have a great day, everyone. Good luck with midterms and midterm finals and mid-finals and finals, all of which seem to be compressed into about 2 weeks at the end of the fall quarter, whatever the fall quarter is defined as anymore. Take care. Good seeing everyone. And Nico, thanks a lot.
Yep. Thanks. See ya.